Morning. So today we're going to get a start on calculus. Okay, so in calculus, one of the main fundamental things is going to be called differentiating. So we're going to start with differentiating from first principles. Okay, so you can see here written down. So it's a major slash fundamental part of calculus is finding the derivative, which is finding the rate of change of a function. And all rate of change is describes how one quantity changes in relation to another quantity. So if we apply a value to x, how that changes in relation to the other variables in there, such as y. So derivative differentiation. This is going to be what we're learning over the next few weeks and how to apply it. So first principles isn't the first method of differentiation you'll be using in like 95% of your questions. There's a quicker, easier way that we'll be learning throughout the week. However, we do need to know first principles as they can directly ask for this method in the exam. It last came up in 2016 and 17, so it could be a possibility this year. So they'll just directly ask you to differentiate or define something using first principles. Therefore, you'd have to go about using this formula here. Okay. So this is the derived function. So this is our formula for first principles. And you can see I've broken it up here into 3 steps that we can follow to get through it. Okay, so this here is our notation for differentiating. Okay, so this is dy over dx, so dy dx. So this is what you'll use, or you can use f dash x. You'll see that too as we go through this week. Either one's the same thing. So we've got f of x plus h minus f of x all over h. So here, example, our f of x is x squared minus 6x. So I want us to differentiate this using first principles. Okay, so step 1 is f of x plus h. Okay, so anywhere that there's an x in the function given, you're going to apply a plus h to it. Okay, so step 1. So we're going to say f of x equals x squared minus 6x. So that was given in the question. So now apply our f of x plus h. So use brackets, okay? So x squared, so x plus h squared minus 6, again, brackets, x plus h. Okay, so that's the first step. Anywhere there's an x, I've added on a h. Okay, so be careful using brackets. So now what I want to do is I want to multiply this out. Okay, so we've got squared here and we've got minus 6 times x plus h here. Okay, so again, you've heard me say this hundreds of times. Off the rough work to do that. Do not do it in your head. Okay, so you've got x times x is x squared, x times h, and then x, so you're going to have 2hx and then h squared. So that is this here squared. So now minus x times 6, or sorry, minus 6 times x is minus 6x, and minus 6 times h is minus 6h. Okay, so that is step 1 done. We've applied our h, we've multiplied it out. Okay, step 2 now is minus f of x. Okay, so I'm taking all this from this formula here. So now we're on step 2. So we've got x plus h minus f of x. So what you need to do is take your answer from the first step, okay? So take your x plus h and take away your original question. Okay, so I'm going to rewrite this out now. So we've got x squared plus 2hx plus h squared minus 6x minus 6h, okay, minus f of x. Okay, so minus your f of x. So again, I apply brackets here. Now the reason I'm applying brackets is just so we don't forget that this is minus all of it, so minus x squared minus 6. So that's going to turn into a plus 6. Okay, so I'm just going to apply that minus now and get rid of these brackets. So x squared plus 2hx plus h squared. So minus x squared is minus x squared, minus 6x is plus 6x. Okay, so just because of that sign, always put brackets in here, so make sure you apply the minus to all of it. So now let's see, hopefully, can anything tidy up a little bit? Can we cancel things out? So we've got a plus x squared and minus x squared, so that's gone. We've got a plus 6x and minus 6x, so that's gone. Okay, so let's write out what we're left with. We've got 2hx plus h squared minus 6h. Okay, so step 1, put on the h. Step 2, take away f of x. And now we're left with this. So step 3, you see here says all over h. So this is taking what we've just found there on top, the numerator, and put that all over h. So I'm just going to move up here for this one. So right now, so x, we just found all that, and then we're going to put it all over h. So it's going to equal 2hx plus h squared minus 6h. Okay, so that's what we've just found, putting that on top, and that goes all over h, and that's our step 3. Okay, so we've got that in format now. So hopefully at this point what you'll be able to do is divide down so you get it into single form, so it's not a fraction anymore. So you're going to divide down the h's. So h goes in h once, and cross it off there, cross 1 off here, so you're left with just h, and cross it off there. So you've got 2x plus h minus 6. Okay, so those h's all cancel out, so you're only left with 1, and we've now got it in single form. Okay, so last but now of the formula is, we can't ignore this limit here. Okay, so limit as h approaches 0. Okay, so there's no big thing here. Alright, all that means is as h goes to 0, we can let that equal 0 here. So you're left with 2x minus 6. So that is differentiated, that's our answer. So dy dx, or as it says third value, you can write it as f dash x. Either notation can be used, equals 2x minus 6. And that is our function, x squared minus 6x differentiated to 2x minus 6. Okay, using first principles. Okay, so we need to, I know it's a bit of a long method, especially when you learn the second one, you'll realise how long this is. But it's something we need to know and we need to be able to use, as we can be asked directly for it. Okay, so it all comes from this formula here that is in your formula book. Step 1 plus h, step 2 minus f of x, step 3 put everything you have so far over h, divide down, apply the limit of h, which just makes it go to 0, and that's your differentiation done. Okay, so I hope this is helpful. I've attached notes and all too, so watch the video a few times, pause, rewind, email me if you need help, and I'll get back to you ASAP.